So hi everyone. Today we'll be discussing about one of the most exciting and unique matrix decomposition algorithm, that is Cholesky decomposition. So basically, in the previous decomposition algorithm that we have discussed, be it LU decomposition or eigenvector decomposition, SV decomposition, we are decomposing the matrix into multiple matrices. Now in this case, we are decomposing the matrix into two matrices, but eventually it is the same matrix. So A equals to L cross L transpose. So basically, you are decomposing a given matrix into a lower triangular matrix, basically. So we're trying to figure out such a matrix whose when we are multiplying it with its transpose, we get the same algorithm. We get the same matrix A. So it is basically majorly driven by rules. So there is no much logic into it. So the first element of the lower triangular matrix would be filled using root square root of the first element of A. The first column of the lower triangular matrix would be filled using this formula ai1, that is first column of A, divided by the first element of L, that we calculated using the above formula. It's completely formula driven, you don't need to apply any logic. The third one being to fill in the diagonal elements. So basically, if you know, a lower triangular matrix doesn't have elements over the diagonal, it will have all the elements below the diagonal. That is, it is called as a triangular matrix. So we won't be filling any value over the diagonal. Just so for now we have taken the first element, we got the first column. So now we will be filling how to fill the diagonal elements of L. So basically, diagonal element of L follows this particular formula: the whole root square of the diagonal elements of A minus summation over the square of all the elements of A in that particular row for which you are filling the diagonal value. So for example, if you are trying to fill L33 equals to root whole square of A33 minus square of L31 plus L32, which we would have been calculated earlier, because we would be filling all these values in a sequential. We won't be filling it randomly. We need to first fill the first row, then the second row, then the third row, and going from left to right. That is why before calculating L33, we would have calculated L31 and L32. Now moving on to all the remaining elements of this lower triangular matrix, that is Lij, we will be using this particular formula. Lij equals to 1 upon Ljj, that means the diagonal element basically. Aij minus summation over Lip into Ljp, where I is greater than j and p goes from 1 to I minus 1. So if you look into the particular example, if you are calculating L43, that is the fourth row, third column, so it would be equals to 1 upon L33. That means the diagonal element of the previous row, because when we are going in a sequential manner from left to right, one row, first row, then the second row, and third row, we won't have calculated the diagonal element of L44, right? So that is why we're considering the diagonal element of the previous row into A43, the value at in the actual matrix, minus L41 into L31 plus L42 into L32. So this is summation over P, where we are doing Lip into Ljp. You need to just for mug up the formulas, and eventually you'll be able to get your matrix decomposition using Cholesky decomposition, that is A equals to L cross L transpose. And do remember that this is a lower triangular matrix, so you eventually won't be filling up the upper triangular matrix for this.